I welcome you all to another video. So here it's all about caching. Now why caching is important? I hope you all know about caching. Caching is basically storing the results in memory to avoid recomputation again and again. And maybe it could be recomputation, it could be making an additional network call to some other service, it could be anything. But yeah, caching basically saves you, it's like accessing things which quickly, smaller things quickly instead of, reading it again from the source file, which could take a lot of time or processing and all. So there's a mechanism to store data in memory for faster access when you reuse it. Yeah, of course, reuse is one of the important things. I mean, you don't want to cache it once if it is only going to be used once, right? Only if it is going to be reused, then it makes sense to perform caching. Okay. It significantly improves the Spark jobs, especially when you need to access the same RDD, which is basically resilient distributed data set for multiple times. And it reduces the computation time because again you have faster access, read time and all. Prevents this by sorting RDD's data in memory. Well, not sorting actually, by storing. Basically when RDD triggers the entire lineage of transformation, it will again all that reduce and everything will happen again and again. So caching basically prevents it by storing that. And it also minimizes disk IO and recomputation, makes better use of CPU and memory resources. Okay, so we can use memory instead of putting all the load on CPU, and then we can always recompute it whenever needed. And it's very good for iterative algorithms and also for the network calls, I would say, because you make a call to input and output operations and all. Okay, so that's about caching, and let's see a demonstration. So this is a very like HDFS is Hadoop, basically accessing the text file from Hadoop system. But again, this is an example. We will see in our case also how. So let's assume that this text file has millions of lines, and in some of those it contains Spark. You need to compute all those lines. So if you do this lines with Spark and dot cache, then all the methods operated over this, like for example count, this will be cached. Okay, first time it would be counted, of course, but second time it will be cached, and then it will be used. So here is an explanation. So we filtered the text file RDD to create new RDD called lines with Spark, which contains only the lines with word Spark. By calling cache, we tell Spark to keep this RDD in memory after the first time it's computed. Okay, so this whole RDD is now kept in the memory. When we call count, Spark computes the RDD, caches it in the memory, and performs the count. When we call collect, the Spark retrieves the cached RDD from memory, avoiding the need to recompute the filter operation. Okay, filter operation meaning this one, lines with Spark and all. So it won't go to RDD, instead it will use the memory, okay, which it already has. Okay, now demonstrating the performance improvement, we will see how this helps and with caching time. Practical considerations, memory usage, it consumes memory, so it's very important that you don't want to store something which is really big into the memory. Okay, ensure that cluster has enough memory to hold cached RDDs. Persistence level, it offers different types of caching such as memory only, memory and disk only. So memory only is everything on memory, memory and disk is percentage, you can distribute this, and then disk only is only on disk. Okay, these are some examples, and I would recommend you reading through the documentation. I mean, if we basically if we actually code all of this, it will take a lot of time. So I'm not putting all of those here, but yeah, I would say just go through these things, see how this is configured. On a high level, I gave you the context. This is in memory. This is stored in our disk meaning the hard disk. Okay, it could be a node cluster, or it could be some kind of basically hard storage. And memory and disk, you can decide the composition based on your requirement. And if you no longer need the cache data, release it to free up the memory. Okay, which is using this unprocessed. Now, use case of caching, iterative algorithms like in machine learning, which is one of my favorite interests. One of the fields, machine learning, deep learning, especially deep reinforcement learning. So things like k-means clustering or PageRank, this require multiple iteration to figure out clustering and all. And these are iterative algorithms. So those things which you don't need to compute again and again, I mean those which are deterministic in nature, and every time you compute it, the output is going to be same. You could use caching to cache those things so that you don't have to go again and again. Like let's say there is an algorithm which basically let's say runs for how many times. Let's say an algorithm runs for 1 million times, and then it outputs Okay, very simple. Let's say something requires sum of 1 million numbers. Okay, sum of 1 million numbers. So if the algorithm runs 1 million times, then it outputs 15. Now next time this again, we don't want to iterate it 1 million times. So caching would be better here, so that we know, okay, we don't need to iterate the sum of 1 million numbers is already 15, like that. So in those iterative algorithms, it's very useful. Interactive analysis, where you are exploring the data and performing multiple actions in an interactive session. So in those cases also, you want to cache the specific things which are going to be reused again and again, and multiple actions on the same data. If your job is I hope you got that context already. Okay, so this is the example that we will be using, similar to this actually, without caching and with caching, we will see, and then we will figure out what is it. Okay, and here's the summary to this. Before we move on to the example, let's read through the summary. So basically, improves performance by keeping frequently accessed RDDs in memory. When you perform multiple actions on the same RDD, be mindful of memory resources when caching large data sets. Okay, because if it is very big, then it could basically I'll try to show you an example of that as well. If it is very big, then it could go out of memory. Your actual instance could go out of memory, and memory performance to demonstrate benefits of caching. Okay, so let's first go with the benefits. So let me bring it here. So this one I have, just to save time, I have just written a code. I'll explain what this is. Actually, let me move. I think we don't need these windows. Yeah. So we create the session as we always do, and let me go to the other chapter 3 and remove this.
It's 18 hours.
Extends app basically extends it to make sure that that's the main class. That's the role of extends app. Okay, so here if we come here, so we have chapter 3 local. Let's make it one node, and just to demonstrate this point, be mindful of memory usage resources. Okay, so what I'm doing is time it is considering large numbers, which is RDD of ints, and identifier, which is string, to add the log. Okay, and here we have start time, then sum of the large numbers, count of the large numbers, average, and then end time. Okay, large numbers is 1 to this many. Let's keep it like this. And then numbers dot filter, where everything is greater than 50,000, which actually 5 lakhs, not 50,000, so 0.5 million you can say. So this one basically will be cached, and then without cache it is like this, so it will go to RDD for our computation. Okay, so we are triggering it once because so that it could be cached, and then later on it could be reused. For 5 iterations we are running with caching and without caching, and expensive operation complete. So let's see what happens when I run this. So let me go to the other terminal. Oops, I think I closed it. No, yeah. So I'll do run. So you can see that because it's a very big number, it's taking some time, and once it runs, then we will see what happens. So here it's running, and you can see that the time taken is, and of course this time may be different if you run this in your machine. It could be different based on the memory you are giving it to, but you can see the difference between without caching and with caching. This is 1401, and then this is almost 3 seconds, almost double, and if the data size grows it can be even more. Okay, and now coming to this point, be mindful of memory resources. So let's just try to increase this one blindly. I'm not sure. Yeah, let's do this. What is it complaining about? Too large. Okay, okay, I think this is the limit. So let me try to run this one. I don't know if I mean, maybe my course can actually take this. However, if not, we will see a big exception. Let's see. Yeah, as expected, Java heap space, out of memory error, right? So this is what I was warning about when I mentioned that be mindful of memory resources, because if your data set is way too large and you are already parallelizing it, it will run out of memory. So you have to be careful. You don't want to cache something which is taking a lot of memory, because it will make your app unresponsive. It can actually, break your main thread or code and all. So always make sure that you should allocate it in such a way that your cores can handle it. If I use all the cores, I'm currently using one. Let's say if I put star, I guess it will work. Let's see. Because now my single core is not handling all this as one cluster. All the cores are involved. So this time it will be able to compute as what I believe. I mean, hopefully it should be. But yeah, let's see. Okay, since we reached this point, so I am assuming I already did. And of course the time would increase, but it's still able to, accommodate it. So you can see that it's 7123, and just see the reduction. It's almost not half, but yeah, almost around 60% to 70%. And these ones, it's almost 1/3, 30, so that's the improvement with caching. And if I go without caching, you see it's taking longer time. Yeah, it will take a lot of resources actually, because it's a big one. See, 15 seconds. And let's see how it goes for the second iteration. And don't worry about the sum. The sum could be, because of the what do you say, some memory issues and all, like 1 to 1, like it is not able to actually display it in positive number. So because it's a 32-bit integer, right? So that's why it's coming like this. But you can see the overall utilization of these things, I mean time. So you can understand why caching is very important. However, we also need to make sure that the memory aspect should be taken care, because if you increase it too much, then you will run out of memory, which can break your entire application. Okay, so I guess it will run one more time, and you can see all these are 2 digits. However, this is only 2.5 seconds. Okay, so this is what I wanted to demonstrate to you. I hope you got a good idea of caching and how it works. You can just do this and tell Spark to keep it in memory. Where is that? Spark.parallelize. Yeah, this particular function you can tell. Okay, and in Python you can also use the same thing. Oops. In Python you can use dot. Let's see. Where is my notebook? Not this. So yeah, okay. So we can create one more block. RDD we already have, right? So RDD cached equal to RDD dot cache. Not sure if it is callable or not. Let's see. Yeah, so this will basically cache your responses. Cache RDD in memory, but make sure it's not too big. Okay, so I hope you got the idea of the caching part and why it's important. Yeah, in case if you have any questions, feel free to ask in the comments. And if you're liking this playlist, make sure to subscribe to the channel for more such content on big data, ML, AI, and full stack development. That's what I've been doing. And yeah, I love technology in general. So yeah, that's all for this video. See you in next video.